Assalamualaikum. Hi. Today we are going to talk about our EMT project. Before we start, we are going to explain first about electromagnetic field. So, what is electromagnetic field? Electromagnetic field is sometimes referred as EM field and is generated when charged particles such as electrons are accelerated. All electrical charged particles are surrounded by electric field. Charged particles in motion produce magnetic field. When the velocity of charged particle changes, an EM field is produced. So, how can we relate the electromagnetic field with our project? In this case, we are trying to detect the presence of the electricity to improve the existence of EMF, especially in our electronic devices and electrical wiring. Then, how can we detect the presence of electricity? One of the examples to detect the presence of electricity is by using the galvanometer. Galvanometer is used for detecting and indicating the electric current. However, in this case, we detect the presence of electricity by converting the EMF to the sound wave for our project.
Whenever a current flows through a wire, it will produce electromagnetic field or EMF. This effect can be increases if the wire is coiled and to make it more electromagnetic by wrapping around ferromagnetic material. Inductor consists of coils that store energy in form of magnetic field. The energy can be produced on its own with power source, which known as self-induced EMF, or from other coil that are being induced, which called as mutually induced EMF. We will focus more on mutually induced EMF. If flux produced by one coil is linked with the second coil, and if change in flux produced by the first coil induce the EMF in the second coil. According to Faraday's law, state that changes in flux induce EMF in coil and changes of current in first coil will induce EMF in the second coil. But then, how does it relate to our project, Elektrosluch? The answer lies on how inductor capture EMF, because any inductors can be self-induced or mutually induced EMF. Since the statement earlier, any current flow through wire will produce EMF. Thus, in this technological world, all electronics or electrical item will have wire and produces EMF. Our electroslush picks up the EMF by mutually induces based on the EMF produced from the device.
Now, the next question to be asked is how can we convert the electrical signal into a sound wave? To do that, we need to understand how speaker works. Speaker push and pull air molecules. It makes them ram into each other in a domino effect. This wave then reach and move our eardrum and make our brain interpret it as sound. The cone of the speaker that push and pull the air molecule is moved by an object called the former. So how actually an electrical signal can produce a force to move the former? The principle of that is introduced by the Andre Mary Ampere, called Ampere's law. If we place our thumb pointing towards the direction of the current, then the magnetic field produced by a coil of wire is following the other fingers that curl towards our palm. This shows that whenever there is a change of direction in current, the direction of the magnetic field will also change. The Ampere's law stated that the amount of magnetic field is proportional to the amount of current. A quick example here, when the current is pointing upward, the magnetic field will turn to the right. Hence, two poles of magnetic field is induced in this situation. Therefore, when we place a permanent magnet inside the wire loop, a motion will be created due to the effect of repelling and attracting between magnets. As we can see from the architecture of the speaker, there is a permanent magnet surrounding a coil. Hence, the changing of polarity by the audio signal moves the coil inwards and outwards accordingly. But most of the time, we want to amplify the low magnitude signal to a higher magnitude. Therefore, an amplifier circuit is introduced between the incoming signal and the speaker. For this example, the inverting amplifier is used, and the amount of gain or the amplification magnitude is as follows. Now we can see that the system has changed to incorporate the need of signal amplification. However, a more practical circuit requires a DC filter circuit. This can be done by placing a capacitor as it rejects the DC component of the signal. The DC component in this case is the power supply provided in the circuit, while AC signal represents our alternating current by the inductor. Now we have completed a basic system for the Elektrosluch. It requires a DC filter, amplifier circuit, and a speaker. The complete circuit of the system is as follows. Notice that we have separated the signal into two channels, as it is common among us to have left and right speaker. The DC filter is placed after the inductor. The inverting amplifier is placed after the DC filter and directly connected to a stereo jack so that we can use our earphone to listen to the sound of the electromagnetic field. However, we want to supply our circuit using a battery. Because battery only produces a single polarity supply, we can add two resistors between the positive and negative terminal to produce a virtual ground. This enables us to have positive and negative supply to be used by the amplifier circuit.
For the application, there are three types of application that we can use the Elektrosluch to detect the sound of electromagnetic field, or we call as EMF. The first application is we use to detect the connectivity in the wire. As the electronic engineer, they need to identify if the wire have the current flow or not. So the Elektrosluch can detect and produce the sound if there is a presence of electromagnetic field. If there is a sound of EMF, it means there is a current moving in the wire. Secondly, we also can use the Elektrosluch to detect the power line through the wall. This device can solve this kind of problem because we are unable to identify the wiring location inside the wall, and it's such a good safety before we start drilling the wall. The third application is this device able to detect the signal from electronic devices such as smartphone, speaker, and many more. This shows that Elektrosluch can detect any electromagnetic field around us and will generate the output via sound. In summary, from this assignment, we know that the moving charge will produce the current, and the moving current it will produce the EMF, and from that we can generate the EMF induce the current in the wire. From that, we can use this device in many types of applications. Besides, there are two subjects of electromagnetic field have been applied in this assignment, which are the mutual inductance and solenoid.